Today we're going to talk about relations and functions. Okay, so let me define for you what a relation is first, because once you know what a relation is, you will see what a function is also. Okay, so actually, function is a special type of a relation. Okay, anyway, let me give you the definition of relation. Relation is nothing more than something that you've actually seen this before. It's nothing more than a set of any order pairs. Here's an example. I just randomly chose some order pairs. You give me any set of order pairs, that's what a relation is. Okay, so write that down. A relation is any set of order pairs. You could have just one member, yeah, if you want to. You could have 2, 3, 4, 1 million. Yeah, you could have infinitely many of them. You're right. It doesn't have to be 4, as what I have, but it could be any set. Any means any number of them. Right? Okay, very good. So write that down. So turns out we have a name for set of the first coordinates of the order pair. You see my order pairs? Can somebody give me the set of my first coordinates? Yes.
Is it 7 and 1?
Oh, that's the first order pair. I'm talking about the first coordinate. So I'm talking about if I were to just gather all the x's. 7, -2, 0, and should I do 7 again? I already said 7. So when it repeats, when you put them in a set, you only write it once. Okay. So set of the first coordinates of the order pair. What I mean by that? 7, -2, 0. And since I have 7 already, okay. What are those x's called altogether? All the x's are called? Anybody remember from last time? It starts with D. Yes. Domain is correct. You guys remember? Domain. These are called the domain of relation. Here, 7, -2, and 0. And then I even wrote this down. You only write it once. Even though I have 2 7s, okay, when you write them in a set notation, you write it once. So set of the first coordinate, right, of the order pair. First coordinates, the x coordinate, right? So basically the x's. Oops. Okay. What do we call then the y coordinates? Starts with R. Romaine? No, it's not romaine. Good guess. Yes. Range. Okay. Good guess though. So it's domain and range. Have you guys heard of domain and range? Yeah. Domains are all the x's, range are all the y. So sometimes domains are all the inputs, and then the range are all the outputs. Right? You guys remember this from previous years? No? These are all the x's and okay, and then here my ranges are 1, 4, 0, and 11, as you can see. Okay. By the way, we like to write things in order. Whenever you write things in a set, you see how I rewrote this as 0, 1, 4, 11? It's always best to write them in increasing order if you can. So even domain, I would have written down this as -2 and then 7. Maybe 0. I mean -2, 0, and 7. That'd be the best. -2, 0, and 7. Okay? Does that make sense, guys? So it's really easy. Domain and range. It sounds real hard. Domain and range are nothing more than all the x coordinates of these relations are called the domain. All the y coordinates are the range. That's it. And you write them without repeating. Okay? You only write it once. Okay? There are many ways of representing these relations. First, maybe you've seen this before. One of the way is to write them as like input and output boxes. I don't know if you guys seen this before, right? -7 goes to 1, -7 and 11, right? -2 goes with 4, 0 goes with 0, right? Another way, of course, is as an order pair, right? This is what I just gave it to you as. Okay, what's another way of representing these relations? Well, if you have it as an order pair, could you plot them on a x and y axis? Yeah, you could just plot them like this. Okay, any question?
Why is it 3 on 4
Why is it what?
3 on one side and 4 on the other
3 on one side, 4 on the other side. Oh, because that's a good question. How come there are only 3 inputs here, and then when there are only 4 outputs? Yeah. Domain, yeah. Yeah, so 7, remember, had 2 outputs. That's why. Remember, we don't write them twice, so we only write it once. That's why you're right. Even though we had 4 order pairs, for inputs, there are 3 of them, remember? There are 3 domains and 4 range. That's why. But you could see by the arrow, right? 7, 1, and then 7, 11. It represents 2 of those points. Good question. Okay. All right, so write those. So you need to know all these 3 ways. Many times, they could give you in any way. You have to, be able to know what they mean, right? When they give it to you this way. So they all represents relation. Okay. Yeah. So there's a mistake. This is really -2, -4, isn't it? -2, 4. Whoops. Should be somewhere above this. So -2, 1. 1, 2, 3, 4. It should be up here. That's good. Okay, thank you. So it should be like this, right? Thank you. I think I had -2, -4 initially, and then I changed my mind. Thank you for noticing. Here it is. All right. So there are 3 ways of represent. There may be more, but right now this is good enough. Okay. So they could either give it to you like a input and output boxes like this, or like as a set. Or like, of course, if you have order pairs, you could always plot them. Okay. As I said before, now function is a special relation. It's kind of like convertible cars, right? Convertible is a car still, right? But convertible is a special type of a car, right? Kind of like function. Function is a relation, but it's special kind of relation. Well, what makes it special is this. A function is a relation in which each input has exactly 1 output. So write that down. That's like the key concept of today. Because we're going to give you a bunch of relations, and we're going to ask you whether or not is this relation a function or not a function. Okay. So
does that mean like you have to write the second?
We'll show you some examples. But write this down first. A function is a relation in which each input has exactly 1 output. Okay, so that's what makes it special. Okay, write it down. So what does this mean? What does it mean to have each input has exactly 1 output? Let me give you an example of a function. Okay, here's an example of a function right here. This is a function. I represent it in 2 different ways, as a graph and as a order pairs, as in a set. Notice each input, like for example, 1. How many outputs does 1 have? 1, which is 3, right? 1 goes with 3, right? Yeah. What about 2? How many outputs does 2 have? 2 has 3 outputs? It has only 1 output, which is 2. 3 has how many outputs? 1, which is 1. Well, how many outputs does 4 have?
0.
Now, how many outputs? 1, and which is 0. How many outputs does -1 have? 1, which is 2. And if I were to plot it, I get this point, right? Let me give you a relation where it's not a function. Take a look at the one we just talked about. This is not a function. How come? Okay, I want you to discuss with your group. Go ahead, I'll wait. Okay, how come this is not a function? All right, how come? What did you guys come up with? Chuck, what did your group come up with? How come this is not a function?
Because 7 has 2 outputs.
Good. It's because 7 has 2 outputs, right? By the way, which one of these methods do you like the best? Yeah, the table, the boxes, right? Because you could see easily 7 has 2 arrows coming out from it. But if I were to give it, but do you think they're gonna give it to you this way every time? No, they could give it to you as an order pair or as a graph, okay? It really depends. But anyway, this one shows you that 7 has 2 outputs, right? Whereas all the other one output, but it doesn't matter. If you could find even 1, then it's not a function. Does that make sense? Yes? You can see that 7 has 2 outputs here. Easy enough? Yes? Okay. That's what I mean by function right here. It says what? A function is a relation in which each input has exactly one output. Does that make sense? Okay. Let's look at some more examples now. Okay, I want you to look at example 3 here, and I want you to plot these points on the x and y axis and tell me whether these set of order pairs are function or not a function. It's a relation, right? Every set of order pair is a relation. Is this a function or not a function? I want you to all discuss. Go ahead, everybody try. All right, so did you all, well, I hope no one really had much problem like plotting these, right, on an x and y axis. Did you all get these points? Okay, now, let's see. Dana, what did your group come up with? Is this relation a function or not a function? It's not a function, you think? How many people agree with her group? A lot of you. How many people think it's a function? Raise your hand. Okay, you guys are? Correct. This is not a function. Okay, Claire, how come this is not a function?
Because 2 has 2 outputs.
Exactly, 2 has 2 outputs. Does that make sense? So even though the best way to show that it's not, easiest way to look at these points, you know, one of the easiest way to represent these graphs, and so, this relation is with that input and output box. If they don't give it to you, actually the graph isn't a nice way to show, isn't that right? Because once you graph them, what do you notice?
It's on the same.
Like it's on the same, what kind of line? X? Not X, it's on the same vertical line. You see what I'm talking about? Look at these 2 points. Right? Look at these points, guys. Aren't they on the same vertical line like this? Right? Do you guys see that? What does that mean? That means for x equals to 2, there were how many outputs? 2. As an order pair, it's not so easy to see unless you look at it carefully. But once you graph them, that's why. Do you see why I asked you to graph? Because once you graph, you can see, oh, if I could draw a vertical line anywhere on the graph, and if it hits it more than once, then it's not a function, because for that x, there were 2 y's. In other words, for that one input, there were 2 outputs. So this can't be a function. Let's see if it worked for the other one. We said this was a function. Can you draw a vertical line anywhere and hit these points more than once? No. What if I like this? Can I do this? Is that a vertical line, guys? No, that's a horizontal line. I'm not talking about horizontal line. I'm talking about vertical line. So be careful, right? Okay, so I'm not talking about. So what about this here? Do you guys remember this example? Look, I could draw a vertical line right here, right? And as you can see, it hits it twice, more than once, correct? So we know it's not a function. Okay, so does that make sense? So that's a nice test, actually, we're going to talk about. But let's do one more. I want you to then decide whether or not, try 3B. I have set of order pairs. I want you to graph and tell me whether or not this is function or not a function. Because some of you are asking me this question. So take a look at these order pairs. I got 2, 3, negative 2, 3, negative 1, 3, and 0, 3. This one's kind of interesting. Go ahead, everybody try. I'll wait. Okay. People got this graph. This graph is kind of interesting. You get a bunch of points that kind of line up as a horizontal line. So how many people? How many people think? How many group come up with? This is a function. Raise your hand. All right. How many people say no? It's not a function. Oh. Okay, few of you. No, that's fine. So let's see. Okay, that's okay. Let me ask you. All right. So, Claire, what do you think? This is not a function.
I don't know. Because there's all the outputs are 3.
Okay, all the outputs are 3. That's what I thought first, right? I thought the same thing. But look, how many outputs? I mean, it doesn't have to be. Like, I could even do it this way, right? Look, right? I could draw these boxes if I wanted to. By the way, if they don't give you these inputs and output boxes, could you draw one yourself if you wanted to? Okay, look, how many outputs does 2 have? 1. Even though it goes to the same number. What about negative 2?
1.
How many? What about negative 1? How many? What about 0? So they all have how many outputs? Even though it's the same number, 1. Guess what? This is a. Would you like to change your mind now?
Yeah.
This is a what? Again, how many people think this is a function? Raise your hand. Okay, does this make sense? You guys are correct now, all of you. This is a function. Again, let's think about that test that we just did. Remember, what sort of line could you draw to see whether or not the order pairs are function or not? Matthew? Vertical line. Draw any vertical line. So it's nice to have a graph, because once you have a graph, if you draw any vertical line, right, it has to hit the graph only how many times? To see whether it's a function or not. How many times?
Twice.
3, 4.
No. Listen to my question. If you want to see whether or not you have a function or not, if you were to draw a vertical line, how many times must it hit
1.
It has to be
in order to be a function?
one.
Just once, okay? You can't hit. If it's not a function, then it's gonna hit more than once. Does that make sense? Okay. Here, for these points, if you were to draw any vertical lines, how many times would it hit? Once. So write this down, guys. There is an easy way to see if. Let me move this up. Okay, hold on. All right. So there is an easy way. Oops. Here we go. There's an easy way to see if a relation is a function. First, you graph the relation. And it's best if they actually give you the graph, right? But if they don't, you can graph the relation, right? Then what? You can use the vertical line test. That's what it's called. By what? So write this down. Vertical line test, how do you do this? Well, relation is a function if and only if no vertical line intersects the graph more than once. Isn't that nice? That's all. So if you have relation, which is a set of order pairs, you graph them and you draw. If you could draw a vertical line that hits it more than once, then it's not a function. Anywhere on the graph, you draw a vertical line anywhere on the graph, and if it hits it more than once, then you know it's not a function. Just easy as that. Isn't this a nice test? What kind of lines do we have to use?
Vertical.
Okay, can I use a horizontal line?
No.
Can I use kind of a line with some slope? No, I must use a vertical line, okay? Because that tells you that for each input, there will be more than one output. Okay, so write this down, I'll wait. This is a very easy test that you could do. This is really easy. This is really nice, okay? So here's what I mean by this. You will see that this is really simple. Take a look at this picture. So let's use a vertical line test to see whether or not this graph is a function or not a function. So I want you to all discuss with your group and see whether or not this is a function or not a function. Go ahead, everybody. I'll wait. Okay. How many group came up with function? Raise your hand. How many will say no? It's not a function. Come on, be brave. Really? No one?
I was brave, guys.
Yeah.
Guys, it's a function.
This is a function. How come this is a function? Yeah, look. Can you draw anywhere a vertical line so that it hit it more than once? No, there is no place. Does that make sense? All right, so we'll do a couple more of these to make sure you understand, because this is really important and it's easy to see. Look, this vertical line test is your friend. It's really nice. So this is a function, okay? Take a, hold on. All right, here we go. Try this one. Now it should just take you seconds. Now don't say it. Just discuss with your group. I'll give you a couple seconds. Go ahead. Oh, I'll give you. Go ahead. Think about this. Shh, don't say it. Just discuss with your group, and then I'll. Okay, think about it. What do you think? All right. How many groups said it's not a function? How many will say it's a function? Okay, you think it's a function? Okay, one person, one brave soul. Shh. Okay. Aiden, what do you think? Shh. Okay, let's listen to Aiden's explanation. Aiden thinks this is a function. Shh. Here we go. Go ahead.
Because, like, oh wait, I meant to say not a function.
You are correct. I'm glad you changed your mind. It's not a function. There's a whole bunch of places where it hits it more than once, right?
Yeah.
Like right here, you know, I could draw one right here. I could do one right here in the middle, right? Okay. So there are a whole bunch of vertical lines you could draw. It'll hit it more than once. Okay. Yeah. So what about then this one here? Okay, everyone think about this. I'll wait. Okay. Don't say it out loud. Just think about it. This time I'm gonna hide the answer. Okay. Is that dot part of this graph? Yes, it is. Okay. And yeah, so you could have a dot. You could have, and these are line segments. These are not lines. Okay. If these were lines, I would have arrows, right? These are line segments. But this dot is part of this graph. Think a part of this relation. So if I, okay, you don't have to be that excited. So we have a dot, part of this relation. Okay, okay, go ahead. Everybody think about this. Is this a function or not a function? I'll wait. All right, how many people say it's a function? How many group come up with this function? One group said it's a function. Okay. Actually, how many people say it's not a function then? Oh, okay. Samuel, what did you say was a function?
We solved the line with
Okay, let me show you this, Samuel.
now we take our line.
Oh, you want to change your mind? Okay. Look at this. Is this a function or not a function? Yeah, look, I could draw a vertical line right there, right? Even though, listen, even though, thank you, even though there are many places where it will only hit it once, even if you find one place, it'll hit it more than once, it's not a function. Okay? So, yeah, this is not a function, definitely, okay? So because of that dot. Now, what if I didn't have that dot? Then this will be a? If I didn't have a dot here, you see this dot right here? If I didn't have that dot, then it would be a function. Okay, does that make sense?
What if the dot wasn't there and those weren't line segments? They were just lines with it.
If these both, okay, good point. If there wasn't a dot and if these were lines, so if I drew arrows, then this would not be a function because right here they will intersect more than once. Does that make sense? Good point. All right, try this one now. This time I give you as an order pair. 5, 0, 5, 1, 5, 2, 0, 4. Go ahead, everybody think about it. You guys are all correct. You guys saw it really quickly. This is not a function, right? Even though you don't have to draw this, you can see. Look, 5 has how many outputs? 3. It's not a function. Okay, your domain is, okay, it's 5, 0, and then range is 0, 1, 2, 3, 4. By the way, on your homework tonight, they're going to ask you to list the domain and list the range. Can you do this? Okay, it's easy. Domains are all the x's, range are all the y's, okay? All right. Okay, here, a couple more. True or false? All lines are functions. True or false? All lines are functions. You're right, it's false. Why? No, there's, yes.
Because a line.
No, it's because of,
X equals.
because of the vertical line. Because, right, vertical line is not a function because you could draw a vertical line on that vertical line. It's going to hit it more than once, obviously. Does that make sense? But what about this? All lines except vertical lines, are they all function then? Yes, all lines except vertical lines are all functions. Does this make sense? Can you do something like this for your homework tonight? Very good, very good.